Hello dear viewers, welcome to TV Mathshub. This is your study pattern for competitive exams. Here you will find different questions, clear solutions, and the guidance you need to succeed. Subscribing is completely free. It is just your way of appreciating our work and supporting the channel. So don't forget to hit the subscribe button and let's learn together. Hello dear viewers, welcome to TV Mathshub. In our today's session, we shall be looking at one of the examples about curve sketching. In our previous video, we looked at some of the basic principles that we follow when we are sketching rational curves. And in case you haven't watched that video, I will put the link in the description. Please check through some of the principles that we follow when we are sketching rational curves. So in our today's session, we shall look at this example, which says that sketch the curve is y, which is equal to x minus 1 into x plus 2 divided by x minus 2 into x plus 1. So this is the curve that we shall be looking at. So to sketch this curve, we shall still follow the same principles that we talked about in our previous video. And these are some of the principles. We said you need to find the intercepts, you find the turning points and their nature. You look at the asymptotes, that is the vertical asymptotes, the horizontal asymptotes. In case there are no horizontal asymptotes, then you will have what we call the slanting asymptotes. And basically, we also talked about finding the regions where the curve exists, where we get the critical points, and that is basically about the range of x. And lastly, you investigate or find the regions where the curve does not exist, and that one is obtained by using your expression that is given. You make a quadratic equation in terms of x, and you put for real roots b squared minus 4ac is greater than 0, and in doing that you are finding the range of y. So those are some of the principles that we shall be following, and without wasting time, let us look at the first one. So the first one is about finding the intercepts. So still I will rewrite our curve here. So our curve is y, which is equal to x minus 1 into x plus 2 divided by x minus 2 into x plus 1. So this is what we have. And the first basic principle that we shall follow is to find the intercept. So let us look at finding intercepts. And we said to find the intercepts, we are basically talking about two things. One is about a y-intercept. And for y-intercepts, we saw that for y-intercept, x is equal to 0. And if x is equal to 0, what will be y? Y will be equaling to, where there is x, put 0. So this will be negative 1 into 2 divided by negative 2 into 1. I'm putting for x equaling to 0 in this expression, and this will give us negative 2 over negative 2, and this will be 1. So our point will be 0 and 1, and this will be our y-intercept. So that is for y-intercept. So next, so this is our y-intercept. So next we shall look at for x-intercept. And we shall be saying that for x-intercept, y is equal to 0. And if y is equal to 0, so it means I will equate this to 0. So I'm having x minus 1 into x plus 2. We are dividing this by x minus 2 into x plus 1, and this is equal to 0. So when you equate this to 0, it means I will remain with x minus 1 into x plus 2, which is equal to 0. And this will give us that either x is equal to 1 or else x is equal to negative 2. So it means our intercepts, therefore our x-intercepts will be 1 0 and then negative 2 0. So there we shall be done with intercepts, and next we shall talk about the turning points. So next let us look at finding the turning points. So how do we find the turning points? We find the turning points, that is at the point where dy dx is equal to 0. So majorly we shall need to get dy dx, but before that, let us try to have this as, y, which is equal to, I want to simplify this expression. So simplifying this expression, this would be x squared. Then x times 2, that would be 2x. Then minus x, that would be plus x. Then minus 2 divided by, this will be x squared. This will be x squared. This will be x. Then minus 2x, that will be minus of x. Then again, this is minus 2. So that is basically what we shall have. So we need, for the turning point, we know for the turning point dy dx is equal to 0. So we need, first of all, get dy dx. So dy dx will be, that is v, which is x squared minus x minus 2 times du dx, that is same as 2x plus 1. Then minus, this is v du dx, then this will be u, and u is x squared plus x minus 2, then times dv dx, which is 2x minus 1. So that is what we shall have, divided by x squared minus x minus 2, the whole of this squared. So from there, we shall have to simplify this further. So before that, okay, we can go on and simplify this. So this will be dy dx, which is equal to, let us simplify this. This is 2x cubed. This times that will be x squared. This times this will be minus 2x squared. This is minus 2x squared. This is minus of x. This is minus 4x. Next, this will be minus 4x. This is minus 2. The whole of this we are subtracting. Then let's also simplify this. This is 2x minus 1. So this will be 2x cubed. This is minus x squared. Then now multiply by this. This is plus 2x squared. This is x times 2x, x times minus x, that is minus, this is x times minus 1, that is minus x, then minus 4x, then plus 2. So that is basically what we shall have. The whole of this is over x squared minus x minus 2, the whole of this squared. Now from there, we can try to simplify this by looking at the terms which will cancel out. We shall have this and this cancelling away. Then this and this will give us minus of x squared, then minus of x squared. So these two and this one will cancel out. So we shall remain with minus 3x here, minus 5x, minus 3x, minus 5x. That will give us, let us see, this is minus 4x. Okay, so this is minus x minus 4x, that is minus 5x. Then this and this is also minus 5x, so this and this will also cancel out. So basically we shall remain with minus 2x squared, and this will also be minus 2 minus 2. So basically we shall have this as minus 2x squared, this one remaining, then minus 2 will give us minus 4. So that is basically what we shall remain with, over x squared minus x minus 2, the whole of this is squared. So this is our dy dx. So after getting dy dx, we need for the turning point. So we shall say for the turning point, dy dx will be equal to 0. So meaning that minus minus 2x squared minus 4, this is, okay, let us have it well here, minus 2x squared minus 4, this is minus 2x squared minus 4 divided by x squared minus x minus 2 squared should be equal to 0. So that is basically what we are having. Okay. So from this given point, we shall have minus 2x squared minus 4 equaling to 0. So meaning 2x squared plus 4 is equal to 0. And this will give us x squared plus 2, which is equal to 0. So x squared will be equal to -2. So from here we shall have the square root of a -2. And we know that a square root of a negative number is complex. So it means x has no real root. So clearly we can easily say that there is no real value for x, because we can easily see that this will give us a complex number, which complex number means that we don't have a real value for x. So there is no real value for x, and this implies that there is no turning point. So this implies that there is no turning point. So we have no turning point for this curve, and if the turning point is not there, then we shall not look at the nature of the turning point. So it means if we had real values for x, then we should go on and get the corresponding value of y. Then we also go on and get the nature of the turning points. But since we don't have what we call the turning points, it means we shall not go for the nature of the turning points. So next we shall look at finding asymptotes. So next we shall talk about finding asymptotes. So let us look at finding asymptotes. In our previous video, we talked about how we get asymptotes and what asymptotes we shall be having when you are given such a curve. So when you have such a curve, first of all, to get the vertical asymptotes, we equate the denominator to 0. So we can easily get that first. So let us talk about vertical asymptotes. So for vertical asymptotes, we equate the denominator to 0. So the denominator is x minus 2 into x plus 1. So we equate this to 0, and we shall be able to get our x, either x is same as 2 or x is same as -1. So this will become our vertical asymptotes. Next, we need to look at either a slanting asymptote or what we call a horizontal asymptote. One of the two must exist. So how do we get, or how do we know that either a slanting asymptote is existing or a horizontal asymptote is existing? We looked at that in our previous video, and now you should be able to tell whether in this curve we have got a horizontal asymptote or a slanting asymptote. Now looking at the degree for x, so here we have x squared, here we have x squared. As we said in our previous video, if the degree of x is less or equal to the degree of x in the numerator is less or equal to the degree of x in the denominator, then it means you will have horizontal asymptotes. But if you find the degree of x in this expression in the numerator is greater than the degree of x in the denominator, then we conclude that it has got slanting asymptote. So for this curve, it will have what we call a horizontal asymptote. So let us look at now a horizontal asymptote. So next we talk about horizontal asymptote. And horizontal asymptote, we said, is a value of y for which x tends to infinity. So let us have our curve. Our curve was x squared. The simplified expression was x squared plus x minus 2. We are dividing this by x squared minus x, then minus 2. So we want to look at how we get what we call the asymptote, which is the horizontal asymptote. So next, to look at the horizontal asymptote, we shall divide each of the terms by the highest power of x. So the highest power of x in this case is x squared. So what we shall do is we shall have y, which is equal to x squared divided by x squared. Divide each of the terms by x squared. So minus 2 divided by x squared, and this is divided by x squared over x squared minus x divided by x squared, then minus 2 divided by x squared. So from here, we shall have this as y, which is equal to 1 plus 1 upon x minus 2 upon x squared. We shall be dividing this by, this is also 1 minus 1 upon x, then minus 2 upon x squared. So that is basically what we shall have as we divide through each of the terms by the highest power of x. So this is the procedure that we shall be following to get the horizontal asymptote. and in case it is a slanting asymptote, then you should also know what exactly you need to do. We said y must be equal to the quotient, so you must use wrong division, then you get the quotient, and that will be your slanting asymptote. But for this question, we are having only the vertical asymptotes and the horizontal asymptotes. So after doing this, we shall now consider our x tending to infinity. So we shall say as x tends to infinity, so where will y be tending to? So we are looking at this expression. Which says that we are having 1 plus 1 upon x. So when you have 1 divided by a very big number, because we are saying x is tending to infinity, so as x tends to infinity, what happens to y? So when you have 1 divided by a very big number, for example, 1 divided by 1 million, 1 divided by 1 million is 0.000001. So you realize that as this number keeps on increasing, then the value is tending to 0. This value is becoming smaller and smaller and is tending to 0. So which means that this will be tending to 0, this will be tending to 0, this will be tending to 0, this will also be tending to 0, because 1 divided by a big number is tends to 0. So it means as this tends to 0, it means your y will be tending to 1 divided by 1, because 1 plus 0 minus 0 remains 1, 1 minus 0 minus 0 remains 1. So it means we shall say that as x is tending to infinity, then y is tending to 1. Y is tending to 1. So hence you will have your horizontal asymptote, hence the horizontal asymptote. So hence the horizontal asymptote is y, which is equal to 1. So this will be the horizontal asymptote. So next we shall talk about finding the regions. Next we shall talk about finding the regions where the curve does not exist. Okay, so how do we find the regions where the curve does not exist? So to find these regions, still we shall consider our curve. Our simplified expression was x squared, then plus x minus 2 divided by x squared minus x. This is minus x, then minus 2. So to find this, we shall simply cross multiply here, and we shall have this as y x squared minus yx minus 2y, which is equal to x squared plus x minus 2. So we need to form a quadratic equation in terms of x. Then we pick the values for b, a, and c. So from here, let us try to rearrange this. So this will be y x squared minus this x squared minus yx minus x. Then next we shall have minus 2y, then plus 2, which is equal to 0. That is basically what we shall have. So from here we can have this as y minus 1 into x squared, then minus of y plus 1 into x, then this I can write it as 2 minus 2y, and this is equal to 0. So from here this will be our a, this will be our b, and this will be our c. So from here, having obtained the quadratic equation in terms of x, then we shall have for real values, we shall say for real values of x, it means b squared minus 4ac should be greater than 0. For real values of x, that must happen. So for that case, we shall have negative of y plus 1 squared minus 4 into a is y minus 1 into 2 minus 2y should be greater than 0. So this is same as having y plus 1 squared, negative squared will give us that, minus 4 into, I want to simplify this, this is 2y, this is minus 2y squared, this is minus 2, then plus 2y, this is greater than 0. So likewise, this will give us y squared plus 2y plus 1, then minus 4 into minus 2y squared. This is plus 4y minus 2 is greater than 0. So we can try to simplify this. This will be y squared plus 2y plus 1. This is plus 8y squared minus 16y plus 8, which is greater than 0. So that is basically what we shall have. When we try to simplify it further, this will be 9y squared. This is minus 14y. And so this is 2y, okay. This and this, then plus 9, which should be greater than 0. So that is basically what we shall have. So next we need the values for y. So to get the critical points for y, we must solve for 9. So let us first consider for 9y squared minus 14y plus 9 equaling to 0. We first solve this to get the values of y, and that will help us now to determine the regions which satisfies this given expression. So we can call this one equation number 1, and we shall refer to it after getting the values of y. So when we have this, so we need the values of y. So this will be 14 minus b, that is 14, plus or minus the square root of negative 14 squared, minus 4 times a times c. Then this is divided by 2 times 9. So this will be 14 plus or minus. So we get, we shall get 14 squared. We subtract 4 times 9 times 9. So 4 times 9 times 9 will give us the square root of minus 128 divided by 18. So when you look at this, still you realize that this will give us a complex number. So this will give us a complex number, meaning that there is no real value for y. So this gives us a complex number, so it means there is no real value for y. So it means we shall say, next we shall have this as there is no real value, because we have seen it is giving a complex number. So we shall say there is no real value. There is no real value of y, and this will mean that, and this means that there is no restriction. There is no restriction. There is no restriction on y. So that is basically what we are getting. However, it is not always that you will always get a complex number here. So in case this is defined, then you have to go on and get the range where the curve is not defined, or where the curve does not exist. So that is what we do. But we shall understand that if we look at another example, that will basically give us this one here defined. That is where we shall have the real values of y. And we go on and see how do we determine the regions where the curve does not exist. So that will be in our next video. So you don't need to miss that video, so you can try to understand better of how we can find the regions where the curve does not exist. But for this question, there is no restriction on y. So that is what we are getting. Now, the next thing to look at is finding the region. That is finding the region where the curve exists. So that is our next target. So our next target is finding the regions where the curve exists. Finding the regions where the curve exists. We have so far seen the regions where the curve does not exist, and we have seen that there is no restriction on y. And since there is no restriction on y, we shall also go on and find the regions where the curve exists. So to find the regions where the curve exists, we are simply looking at the range for x. So to find the range for x, or to find those regions, we shall consider what we call the critical points. We shall consider what we call the critical points. And how do we get the critical points? To obtain the critical points, you will simply go to your curve given. So we have our curve here. So you equate each of the denominator and the numerator to 0. So equate this to 0, equate the whole of this to 0. And what you get becomes the critical points. So let us look at that. So our critical points will be, let us equate our curve to 0. We equate the denominator and the numerator to 0. So our numerator was x, it was x minus 1 into x plus 2. So we equate this to 0 and get the values for x. So when you equate this to 0, it implies your x minus 1 will be equal to 0, which will give us x as 1, or your x will be negative 2. Go on and equate this is the numerator to 0. Then we equate also the denominator to 0. And when we equate the denominator to 0, the denominator was x minus 2 into x plus 1. So we also equate this to 0. So when you equate this to 0, you will have your x as 2 or your x as a negative 1. So after getting that, it means your critical values or critical points will be, so critical points are the critical points or values. So the critical values will be, now try to arrange them in the order starting with the smallest. So the smallest is negative 2. We shall have negative 1. We shall have 1 and then 2. So these are our critical values. So now we shall make a table for the regions which are defined by these critical values. So how do we make that? We shall make a table here. We shall make a table where we shall look at the different regions. So we shall have this as, so we shall have our table here. So this will be to test the different regions, and we shall start with the region which is less than negative 2. So maybe we can put it on a fresh page. So we are having our critical points. So let me rewrite that. Critical points or critical values. Our critical values are negative 2, negative 1, then 1 and 2. So those are our values. So we shall make a table here, and this table will be testing different regions. So the first one will be x less than negative 2. So you test the region which is less than this. You test the region which is greater than that. The region which is between this, the region between that, and the region between that. So those are the different regions that we shall be testing. So the region 1 is x less than negative 2. Then another one is the region between this and that. That is negative 2 is less x is less negative 1. That is another region. Then another region to test will be the region which is between negative 1 less x less than 1. That is another region you will test. Next you will test for the region which is 1 less than x less than 2. And lastly you will test for the region which is x greater than 2. So after arranging your critical points, you test for the regions. That is the region less than negative 2, the regions between these two numbers, the region between these two numbers, the region between this, and the region which is above. So that is how we look at where the curve exists. That is the major principle that we follow. So after that, remember we are having our curve, which is x. Our curve is x minus 1 into x plus 2 divided by x plus 2. That is x minus 2 into x plus 1. This is what we are having. So we need to test for y in each of these different regions. But before doing that, we shall try to split this into the corresponding components. So the components are, we have x minus 1, so we shall have it there as x minus 1. The next one is x plus 2. I'm beginning with the numerator, x plus 2. And the next one, now after getting these two, I can now get x minus 1 into x plus 2. After getting that, it means I've got now the expression in the numerator. And now I look at the expression in the denominator. It is beginning with x minus 2, so I first deal with that. We are trying to simplify this expression. Then I have x plus 1. I also put it there. And now we shall now have the denominator, which is x minus 2 into x plus 1. So that will be the denominator. Now the final expression is y equaling to that. So this is x minus 1 into x plus 2. Then we are dividing this by x minus 2 into x plus 1. So we need to look at the sign changes. We need to look at the sign change of the function. throughout the domain. So the function will only change the signs where the curve cuts the x-axis and at vertical asymptotes. So these are the things that we shall be considering here. We shall only be interested in the sign change. So here we shall be testing for these different regions using these expressions here. But our major target is to know what is the sign for y in each of these regions. So it is better to first split it into different components because it will be easier for you now when you start dealing with this expression. Now from here, let us begin. We shall begin by looking at each of these. So we need the value of x which is less than -2. So you can put your x as, for example, -3. So when you put -3 in here, it will give us -3 minus 1, which will be a minus. -3, when you put it here, it will give us still a minus because -3 plus 2 is a minus. So you are simply interested in the sign value. So when you put, now we have got this and this, so we are multiplying the two. It is same as multiplying this and this. Negative and a minus will give us a positive. So minus times a minus will give us a positive. Then next, when you put -3 here, it will give us a minus. -3 here, it is a minus. Multiply the two, it will give us a positive. And lastly, we need to divide this with this. So you are dividing a positive with a positive, and the result will be a positive. Next, you need a value between -2 and -1. That value can be your x as a -1.5. So if you put -1.5 here, it will still give us a minus. Put it here, it will give us a positive. So minus times a positive to get this will give us a minus. Then next, put -1.5 here, it will give us minus. Put -1.5 there, it will give us a minus. Multiply these two to get this, it will give us a positive. So next we need to divide this with this, so we shall get a minus. Then next we need a value between -1 and 1. That value we can take 0. So 0, when you place it here, it will be minus. Place it here, it will be positive. The result is multiplying the two, which will give us a minus. Next, place 0 here, it will give us a minus. Place 0 here, it will give us, okay, this was a minus. Place 0 here, it will give us a positive. Now multiply this and this, it will give us a minus. And lastly, we need to multiply this, and this will give us a positive. So that is what we are getting. Next, we shall have 1 less than x less than 2. We can take a point like x equaling to 1.5. Place it here, it will give us a positive. Place it here, it will give us a positive. So the result will still be a positive. 1.5 placed here will give us a minus. Placed here will give us a positive. Multiply the two, you will get a minus. And lastly, we multiply this and this to get, we divide this and this to get the final expression, and that will be a minus. Then lastly, place a number like x equaling to 3. Place any number so long as it is greater than 2. Whatever you get, these are not the must values that you have to use. You can choose any other values for x so long as they are within that given range. So here you can take x as 3. So this will give us a positive. Place 3 here, it will give us a positive still. The result of multiplying the two will be a positive. Then place 3 here, it will give us a positive. Place 3 in x plus 1, it will give us a 4, which is a positive. The result of multiplying this and this will be a positive. Now I need to divide this and this, which will be a positive. So that will be the nature of our curve in these given ranges. So next, we need now to look at sketching. So we have looked at so far. We have determined the range where the curve exists. We have seen the range where the curve does not exist, and we have seen there is no restriction on y. We have got the asymptotes, that is the horizontal asymptote and vertical asymptote, and we have got the turning points. Actually, the turning points are not there because they are no real values of x. And lastly, we also got the intercepts. So let us look at the sketch. So now, to look at the sketch, you need to sketch using what we have obtained here. We have the intercept, so we shall need to put the intercept. So we have got our intercept. We shall try to place these intercepts there. So we have got these intercepts, that is 1 and 0. That is the x-intercept, 1 and 0. So 1 and 0, this we can name it well. This is our major line. that is the 0, 0 line, this one here. So this is where you have your y, this is where you have your x, like this. Okay, so this our major axis. Now we need to put the intercepts. So when we look at the intercepts, we have a 0, 1, that was y-intercept. So y-intercept 0, 1. So we are putting that 0, 1. So our 0 and 1, this is where we have 0, 0. This is a point where we have 0, 0. So this is our 0, 0. So 0, 1 will be this. This is our 0, 1. Next, you have this point here, that is the point 1, 0. So this is the x-intercept 1, 0. Then next we have our intercept again, which is negative 2, 0. So negative 2, 0. This is 0, 0. So this is negative 1. Negative 2, 0 is this point. Negative 2 and 0 is that point. So we shall now put the intercepts. Now we have put the intercepts. Now next you need to put your asymptotes. The asymptotes we use dotted lines. So this is our vertical asymptote. This was x equaling to 2 and this was x equaling to negative 1. These are our asymptotes. So let us go back to the curve. So we have already allocated the intercepts on our curve. So next we talk about, we don't have the turning points, so we shall not put that. Then the asymptotes, we have seen we have 2 and negative 1. 2 and negative 1 are our vertical asymptotes. So looking at those, 2, negative 1, these are the lines. This is for x equaling 2. This is for x equaling to negative 1. It must be dotted. Asymptotes shall be dotted. Then this is also x equaling to 2. This one here. So those are the asymptotes we are having. So the next one was a slanting asymptote. The next was a slanting asymptote, which is this one, y is equal to 1. So from our curve here, we shall allocate that one there, and that is this dotted one. That is the vertical asymptote, which is, this is the horizontal asymptote, which is y is equal to 1. These are the vertical asymptotes, the one with red dotted lines. Now, from there, after you have placed or put these lines here, indicating your asymptotes, so the next thing will be now to draw the curve. Now, we have seen that there is no limitation. We have seen that there is no limitation on y. As we are looking at finding the regions where the curve does not exist, we have seen there is no restriction on y. So y will have no any restriction. So the next thing we shall look at will be that is the regions where the curve exists. And we have obtained these regions as that. Now, how shall we use these regions? We have the regions x less than negative 2, negative 2 less x less negative 1, negative 1 less x less 1, 1 less x less 2, and that. So next, the next thing to do, since we have no turning points, we have filled the information that we so far have. So the next thing will be to draw the curve. So how do you draw the curve? The curve will be drawn depending on the nature of the curve in these different regions. So we had the region which is greater than, that is x less than negative 2. And in this region of x less than negative 2, the curve is positive. So when we come here, we shall go to that region of x less than negative 2. So that region of x less than negative 2 is this region. So here is where we have x equaling to negative 2. So this is the line that we are talking about. So in this side here, our curve must be positive. So that's why we are bringing our curve, because this is a 0 line. This is a 0 line here. This is a 0 line. So our curve, this is our line, which is x is equal to negative 2. So less than this, the curve must be positive. So since we don't have any intercepts along this line here, so the curve will be in this positive part. So this is our asymptote, which was y is equal to 1, the horizontal asymptote. So the curve will move along this line here. That is, does not pass through this, so it will move along this line, but make sure that that curve is positive. So you realize that above this, our curve will be positive. Now here there is an intercept. So this was an intercept which was negative 2 and 0. So next, the region which is between -1 and -2 and -1, the curve was positive. So when it comes like this, it passes through the intercept, then it goes along this asymptote, which is x equaling to -1. So that's why we are having such a curve moving like that. It passes through the intercept, and from there then it goes along this line here. It should not pass through the vertical asymptote. So the curve cannot pass through the vertical asymptote. But we shall also look at some scenarios where the curve can cross the horizontal asymptote. Even here, you can realize that the curve is crossing this. So this one is possible. So, but it can never cross what we call the vertical asymptote. So next, we need now, we have seen that our curve here is positive. That is the reason why we have this table here. We have seen now here in this region, the curve must be positive. In this region of -2, -1, the curve must be negative, and that is why it is in the negative direction. So it passes through this intercept, it goes in the negative direction, but it should not cross this vertical asymptote. Then next, in the region between -1 and 0, -1 and 0. So next, in the region between -1 and 0, in the region between -1, actually it is -1 to 1. In the region between -1 to 1, the curve must be positive. So in this region here, the curve must be positive. So here we have our intercept. So it means the curve in this region, it must be positive. So it must come along this asymptote here. So it comes along that because this is an intercept, so it must go through this intercept. So this was intercept 1, 0. So it goes through this intercept. So it passes through this point, but still you realize that between -1 and 1, it is still positive because this is our zero line. This one here is our zero line. So you realize that here in this region here, it is still positive. So this region, it is positive. Then the next region is between 1 and 2. So the next region is between 1 and 2. So between 1 and 2, the curve is negative. So it passes through this point here, but here we have a vertical asymptote. So this vertical asymptote, as I said, it cannot never be crossed by a curve. So it will move again in this region in the negative direction. So that's why our curve moves again in this direction, and it moves along this asymptote here. So that is the nature of our curve in this given region. So the next region is the region which is above 2. The region which is above 2, as we can see, x greater than 2 is a positive. So if it is positive, then so we shall have. So next, in this region which is x greater than 2, the curve is positive. So that's why it is again in this positive part. So this is the positive part. So it moves along that line there, and that is how it will be looking like. So this is basically how we can sketch rational curves. So the most important thing is, after you have got your asymptotes, make sure that when you are drawing your asymptotes, you are using dotted lines. So you draw your horizontal asymptote, you draw your vertical asymptote, then put the intercepts. Then after the intercepts, then if they are turning points, you can also put them. Then, of course, after getting the turning points, you must need to look at the nature of the turning points. And after you have done all that, then you can now do the sketch. You don't need to forget the regions where the curve exists and it does not exist, because it will give you how the curve will be moving like. So you can realize that if it is the region like x less than -2, the curve must be positive. So you make sure that the curve is in the positive part for y. So if it is a minus, it means your curve or your y will be in the y direction, which is a minus. So you can realize that along this, the curve is in the negative direction, and along between -1 to 1, you realize that your curve is still positive, because in this direction it is positive. Then in this region it must be negative, so that's why it comes along and comes there. As I said, the curve cannot cross this line here. The curve cannot cross the vertical asymptotes, because along the vertical asymptotes, that's where the curve is undefined, so it cannot cross. So that's why it moves, passes through the intercept and moves across this, and we are not again joining it with these ones here. Then here it starts in the positive, then again moves and comes back in the negative. So it must pass through the intercepts. Your curve must pass through the intercepts if you have them. Also, if you have the turning points, it must pass through the turning points. So those are some of the things that we consider when you are sketching. So that is our example number 1, and please don't miss our example number 2. It will be an example that will be containing the turning points, where it also contains the restricted part of y, that is the where the curve does not exist, such that we now get the concept very well, and you use the same concept now to do some different questions. So using this example and another example, we'll try to summarize all the necessary information that you need to make sure that you get all the 12 marks in curve sketching.